We're just not getting enough heat off the planet. It's as simple and complex as that. How bad is it? In 2007, January, the long-anticipated fourth report of the UN Intergovernmental Panel on Climate Change was published. 2,500 scientists, 100 countries, the best and brightest across every discipline. After years and years of study and models and field experimentation, they came up with their fourth report conclusions. It's very, very sobering. The first thing that strikes us when we read this report is how we so grossly underestimated the speed of climate change in all of our projections previously. The reason is we couldn't take into anticipation all the feedback loops. For example, if you go back to the third report, what was that, 2001, their scientists were saying at that point that we might see the great glaciers on our mountain range disappear by the early 22nd century. In this new fourth report, we see the glaciers are melting in real time in the first 50 years of this century. Now this is important because 1/6 of the population of the world, human population, relies on those glaciers because they live down in the valleys and they rely on the irrigation of the water. The third report, just a few years earlier, said that we might see by the 22nd century more intense hurricane activity in the Gulf Stream. That's a test case. The fourth report says we've doubled the intensity of hurricanes in the last 30 years. Hurricane Katrina and Rita, those were real-time climate change events. And of course, the third report said look to the Arctic. That's the canary in the mine, because that's where we're going to get an early warning system. And the scientists projected that by the early 22nd century, that water in the Arctic could be an open navigational passage, a northwest passage for commerce. The fourth report, the polar bears are drowning now. And we're going to see a navigable ocean up in the Arctic by 2030. The feedback loops are important because if you open up the front page of The Guardian this morning, there's a report by one of our top climatologists at NASA, Mr. Hansen. And he said, we are really under-projecting the speed because as they began to look at the real-time consequences and the feedback loops, we're moving in even quicker than the fourth report said. I'm going to give you just one example. While the fourth report mentioned permafrost of Siberia, they didn't model in the feedback. Now, why is permafrost important? If you've ever traveled on a plane across Siberia, this vast, vast open expanse, and the permafrost on the ground is a tomb. And what's buried in that permafrost is the last period of history before the Ice Age. The Siberian subcontinent was teeming with plant and animal life before the last Ice Age. That animal and plant life became entombed in a time capsule in the permafrost. The permafrost is melting really quickly. And it's releasing massive carbon. More carbon than all our rainforests in the world. But what's even more difficult, which we didn't anticipate in the studies, is when all of that permafrost melts, it's creating millions of little lakelets. The carbon's going into the water and coming up as methane. Methane's 23 times more potent than CO2. We're talking about a massive, catastrophic release of carbon from a previous period of history. We didn't model this. That's only one feedback loop. Let me just share with you two statistics. In this new report of the United Nations Scientific Panel, they model various scenarios. The middle scenario, which I think is optimistic, is a 3-degree rise centigrade Celsius in temperature in this century. But as you'll see in the new reports that just came out, it could be 6 degrees, 7 degrees, 8 degrees, 9 degrees. There are even models saying 10, 11, and 12. But to put this in perspective, a 3-degree Celsius rise in temperature in this planet, in this century, the century of your children and grandchildren, that takes us back to the temperature on Earth 3 million years ago in the Pliocene. This is a whole different world then. Different flora, different fauna, different ecosystems. If we go 2 degrees Celsius to 3 degrees, now remember the European Union is trying to get the world to 2 degrees. But even if we just get to 2 to 3 degrees, our scientists say that between 30% And 70% of all the remaining plant and animal species on this little planet could be threatened with extinction. Let me put this in perspective. We've had 5 waves of biological extinction on this planet in 450 million years. And every time there was a massive wipeout of flora and fauna, it took 10 million years to recover the biodiversity loss. As my wife says, we are not grasping the enormity of this moment. We're not grasping it in public policy. We're not grasping it on the ground. We're not grasping it at the dinner table. We are at a turning point in human history. If our scientists are only half right, we're at a turning point in which we have to now think about the future of our species. Not in 1,000 years, but in a lifetime of your heirs, your children and grandchildren in this century. And we have to think of our fellow creatures. And the biosphere, this little planet in the universe, which has something we call life. You know, we've been sending out those radio waves for what, 25, 30 years across the universe? Is anyone home? Nobody's calling us back. This is a very precious little experiment. We're not sure what it is, life. We're not even sure what the meaning of it is, but it's something very, very special in the universe. If we were to measure human impact in terms of sheer power, we'd probably have to conclude that climate change is the greatest event of our species. It's a negative one, but we've actually affected the entire chemistry of the planet, and most of it in less than 100 years. That's dramatic. No other species can claim that. Climate change, the end of the fossil fuel era. Let me also spend a moment on peak oil. Now, peak oil is a petrogeology term, and it's what we call the Hubbert classic bell curve. Peak oil is when half of the world's oil is used up. It's the top of the classic bell curve. Interesting enough, when half the oil is used up, that's the end of the oil era. Because once you reach the top of that bell curve, you can't afford the prices on the other side. When do we reach peak? The optimists believe that we might reach peak between 2020 and 2030. The pessimists say, among the scientists, we're going to reach peak between 2010 and 2020. Some say we've already peaked. I have no idea who's right. If you read my book, The Hydrogen Economy, in chapter 2, it's a kind of a tedious chapter actually, I kept going back and forth between the scientists trying to figure out who's right, the pessimists or the optimists. Then after months of micromanaging the data, I realized it didn't make any difference who was right. They're only arguing about 10 or 15 years here. That is a very small window to change the entire energy regime, the entire infrastructure based on it, and all the goods and services we rely on to maintain civilization. It takes my breath away to think of that short window and what we need to do. And let's be clear about the conclusions of the UN scientific panel. They said we've got 7 to 10 years, we the human race, to get one roadmap. The whole human race has to be on the same map. We can't make any mistakes because there's no going back. We got a very, very short window to save our species. Our scientists have given us a very sober analysis. What we need now is to imagine an economic game plan that might be powerful enough to address the enormity of climate change and peak oil. The great economic revolutions in history, the big ones, they occur when 2 things happen. First, a basic change in the way we humans organize the energy of our planet. And then second, a basic change in the way we communicate with each other to organize new energy regimes. It is the coming together, the convergence of energy revolutions and communication revolutions. When they come together, those are the pivotal points in history. They really do change the human equation for long periods of time. I'm going to give you an example. Some of you had cultural anthropology at university. You may have remembered studying the Sumerians, Mesopotamia. Why are they interesting to us? Because they were the first to create high-end hydraulic agriculture. They captured the sun through photosynthesis in plants. The stored grain became